bioprocess control lab. Okay, so experiments that are related to the bioprocess control lab. So if you see what are the experiments you are having, you will be having the first experiment as characteristics of an on-off controller. Okay. The second experiment will be about the PI controller. Okay, PI, PID, and so on. Okay. And the third experiment will be about your temperature. Okay, temperature control. Fourth experiment will be about your level control, and the fifth experiment will be about your uh, I mean flow control. Okay, so you have temperature, flow, level. So these three parameters you will be measuring using your using your control systems. Okay, and apart from that, you are going to generally study the characteristics of an on-off controller, and also you are going to study the characteristics of a proportional or integral or P plus I or PID controller and so on. Okay. So for that, what you are going to do is we will be just using a simulation package called as Matlab. So the expansion for Matlab is Matrix Laboratory actually. Okay, the expansion for Matlab is Matrix Laboratory. So you have to install Matlab in your system, and once it is installed, you can see that there is an icon. Okay, so you can see an icon on the desktop. By clicking the icon, you can open the MATLAB. Okay. So once when you open the MATLAB, you will be having an environment like what you see there. Okay. You have a current folder, then you have an editor. Okay. Then you have the command window, all this. Okay. And using this editor, okay, what you can do is you can type the program actually. Okay, you can type the program, and you can just execute the program and debug the errors. Okay, and you can also find the output. So this is like where you have to write few sentences of coding. Okay, and there is also another type of programming here where you need not write lines of coding, but you only have to drag and drop the components. Okay, you only have to drag and drop the components. So that is called as Simulink. Okay, so that is called as Simulink. Okay, so you see an icon here like Simulink, right? So this is an inbuilt library. From this inbuilt library, you can fetch whatever components or whatever blocks you want. You can fetch, and you can drop it on to the you can drop it on to your this thing. What I can say, you can drop it on to your model file. Okay, so how to open the model file? If you are opening a new model file, you have to click here new. Okay, so if you want to write coding, then go and open the script. Okay, if you want to go for building a Simulink model, then you go to this option Simulink model, and you click like this. Okay, if you just open the Simulink model, you will have an untitled window which is getting opened. Okay. Right. So in this case, you are having a blank model. You are going to create a new model. So go and open the blank model. So you are getting an untitled window here. After building your experiment, you can just rename the file, and you can execute it. So now we are going to do on-off control actually. Okay. So for doing on-off control, before doing on-off control, you must open the library also, right? Because without the library, Okay. Without the library, I will not be able to do. Can you see the library? What is being shared? Can you open? Can you see that?
Yes, ma'am.
Yeah. Okay. Untitled Simulink file will be opened. Okay. Then you have to click this. So when you click that, you will have the. One second. So you will have the window to be opened like this. Then this is the library actually. So click on the library. So you will have the components to be opened. Okay. You have the components to be opened. Now you are going to build a on-off controller. Okay. So for building the on-off controller, first you require an input. Okay. So go to commonly used blocks. Okay. So by going to commonly used blocks, so you have to take the block called constant. So from constant only you are going to give the input. So simply if you drag and drop, you will get the constant there. Okay. Okay. So I took the constant block and I have included here. Now I want to change the value. So to change the value, double click on the same thing. Okay. When you double click, you have the block parameters to be opening. So in this you can change. Okay. So I will make it to 22. Okay. Some value I will make. Okay. So I am making it as 22. Okay. And I am just fixing the value for this constant block to be 22. Okay. Then I am going to build a closed loop system. Okay. I am going to build a closed loop system. So for that, I will be requiring a summer. Okay. Because I have to take the feedback connection and give. So I'll be requiring a summer. Okay. Now in the summer, I'll be using a positive feedback actually. Okay. I'll be using a negative feedback. When I'm using a negative feedback, the symbol here should be a minus sign. Okay. The feedback path should have a minus sign. If you remember, when taking the theory classes, I would have taught you about the open loop and closed loop systems. Okay. Closed loop systems are the systems one which is going to have a feedback path. Okay. Uh, and if you take a open loop system, there won't be any connection coming from output to input. But in the case of the closed loop system, you have at least one connection that is taken from the output end and connected to the input end. Okay. So now here this is the feedback connection. If the plus sign is here, that means you are using a positive feedback. If you put a negative sign, then it becomes a negative feedback. Normally, we go in for negative feedback. Okay. So, what I will do is I will connect this constant block to the summer. Okay. And I'm going to change this to negative feedback. Okay. I'm going to change this to negative feedback. So, double click on this. See, you are having the sign. Okay. So, just delete the one plus sign and give minus sign. Okay. And give OK so that it becomes a negative feedback. Okay. So that it becomes a negative feedback. Okay. Then you want, then you want a process. Okay. So you have to visualize the output. For that you require for that you require a CRO, right? So CRO is your scope. Okay. So I'm taking a scope. Okay. So I'm taking a scope and placing. Okay. Scope means that is your CRO actually. Okay. So this is the input from where you can connect any block to the input of the CRO. And this is a multiplexer where you can add up two signals together. Okay. So okay, so using the multiplexer, you can combine two signals and get one single output. So that is why you see on the input end there are two ports. Okay, and at the output end there is only one port. So you can combine two signals using using your multiplexer. So that is called as your mux. Okay. Then you want a process, right? You want a process and you want a on-off control. Okay. So for a process, for getting the process, what you do, you click on the continuous. Okay. So now when you click the continuous, you have the transfer function block here. Okay. Now you drag this transfer function block and place it here. Okay. And I am going to, my transfer function will be 1 divided by 1 plus 5s actually. Okay. So to change that, what I do is I double click on this block once again. So the numerator coefficient is 1. So it is 1 here. Okay. The denominator coefficient should be 5s plus 1. So I have to change this 1 to 5 and give OK. When I give OK, I will get 5s plus 1. Okay. Then this is the scope. Okay. Then I want a relay actually. Relay is either on or off. Okay. So relay is an example of on-off controller. So next I must choose a relay actually. Right. For
Ma'am,
choosing the relay. Yes, please.
ma'am, உங்களோட current screen உங்களுக்கு share ஆகல ma'am.
Current screen share away. Wait, one second. Now can you see? Can you now see the screen?
Yes,
Can you
yes
see
ma'am.
the screen now? Yes. Okay. Okay, I don't know how to share the two screens actually. Actually, this components will be available in this library actually. So this library you have to open. Okay. So when you click this library, you will have all these components. This is your constant block actually, and this is a summer block. This is the transfer function block. This is the Simulink. Okay, I mean sorry. This is the multiplexer block, and these two are the CRO. Okay, these two are the CRO now, right? So what you have to do is now you want a relay, okay? So for obtaining the relay, what I should do is I must just go for the discontinuous, discontinuity. I have to in the Simulink library, I have to go and take discontinuity, and I have to pick up the relay. Okay, I have to pick up the relay and I have to place it here. Okay, I have to pick up the relay and place it here. Are you able to see the relay what is placed? Yes, no? Students, can you see the relay?
Yes,
Okay.
ma'am.
So now you can just connect this output of the summer to the relay. Okay. And this is the mux. So I'm connecting the relay here. So open the relay block also. When you click on the relay block, what will happen is you can just see you are having output 0, 1 and so on, right? And also you can see you can change this. I'll put it in inherited, okay? I'll put in inherited, okay? And also uh, I'll just give okay. So now here, okay. Hmm. So from this multiplexer, I'm going to connect to the output of the relay, and from this end, I'm going to connect to the input. Then from here I am going to connect to the scope, right? I have connected to the scope. Now from this one I'm connecting to another scope. So this is the process output actually. Okay, this is the process output. Okay. Now this feedback part I have to once again connect it here. Okay. Right. So I have connected. Right. So now after doing this connection, might be I will require one more block is missing actually. At the output of the relay, I have to give the gain. Okay. So at the output of the relay, I have to give a gain block. I missed that. Okay. So once again, for obtaining the gain block, I have to go to the commonly used block. From that, I have to pick up the gain. Okay. And I have to put the gain block. Okay. So now what I will do, I will just so from this constant, I have to connect to the drum. Okay. I finished that. Now I can change the value of the constant. I want to make it 30. Right? So this is element wise. Now I will change it to matrix wise. I will put 30. Okay. So this is build up. Okay. Now I have to save. Okay. So I have to save the file. So go to the file. Okay. So save as I'm saving uh, experiment 1 1. Okay. So the model is getting saved now. Okay. So once the model is saved, I can change the runtime. So this is 10 seconds or something like that, 10 seconds. So I can make it to 20 seconds if I want. Okay. Then once again I must save. When I change the time, I must save once again. Okay. Then you see this green color icon. So this is the icon that is used for executing your program or the model whichever you have built. See, actually I have left one more connection here. I'm connecting it here. Okay. Okay. Now I will just simulate. So the model is getting compiled. Once the compilation is over, if I click on the scope, okay, if I click on the scope, I will be able to see the output. right? So I'll be getting the output for the on-off controller. Okay, so I can change this and see zero crossing detection. So I'm getting the output for the on-off controller. Okay, by applying the on-off controller, I'm getting the process output. This is the process output actually. If I want to see the on-off controller output, that is the input to the controller, right? So I'm getting the output for the on-off controller as well as the output of the process together here. Okay. If you see the output for the on-off controller, it is either 0 or 1, right? So that is why the curve is reaching 0 or 1. Okay. So I have one more experiment with me. The same experiment what I have built up, right? See, I'll simulate this one. Okay. I simulated this. So I'm getting the output for the on-off controller, right? So you can just save this graph with you, and you can discuss about how the characteristics will be. Okay. So this is how your on-off controller is going to behave. So this is about your first experiment actually. Okay. Can you understand, students?
Yes, ma'am.